In this video, I want to discuss what happens when we find the area between two regions, but we have multiple regions that are created. So in example 1, we have x to the third minus 3x plus 3, and g of x equals x plus 3. Well, if I look at the graph of this, again, we can go ahead and put this into our y equals, and look at these two equations. So we have x to the third minus our 3x plus 3. y2 is going to be our x plus 3. Again, this is probably going to be a graphing calculator question so that we can see what we're doing with it. But if I graph this, here comes my x to the third, and here comes my linear function x plus 3. Notice we have two areas that are created, and our top curve switches between these two regions. So if I draw this out, notice we have this curve comes up, goes down, comes back up. There's my cubic, and then here's my linear, if I can draw it somewhat accurately. So notice we have two areas that are created. And we know that our top curve over here, from that point to that point, that equation is the same as the bottom curve over here. So in order to find this integration, this area, I'm going to have to set up two integrations, or two integrals. So I'm going to go from the integration of a to b, because I don't necessarily know what they are at this point in time. I can take an educated guess of this function, my top curve, which is going to be my cubic, my f of x, minus my bottom curve, which is g of x dx. And to that, we're going to add the integration from b, and we'll call this value c, this x value, of now our top curve becomes the linear function, our g of x minus f of x dx. And since we're using our calculator, it may be helpful to come back here and say, well, y1 is x to the third, that's our f of x, and our y2 is g of x. So here we have y2 minus our y1. So now what we can do is find those points of intersection. Well, to find the points of intersection, we can go ahead and calculate the intersection point. Go ahead and find one of them. We see that we have the intersection of 0, 3. That's going to be the middle point. So we know that B is going to be 0. We can do this again. Find the point of intersection. Move our cursor a little closer to that next point of intersection. Hitting enter, we have x equals -2. And one more time, point of intersection over here. Moving our cursor, hitting enter, and we see that it is equal to 2. Since they're nice, clean numbers, we don't have to store anything in our calculator. If we didn't, we'd have to go ahead and store that into our calculator so we could use them. So what are we looking at? We're looking at the integration from -2 to 0 of y1 minus y2 dx, plus the integration from 0 to 2 of y2 minus y1 dx. We can do our math 9. Clear first. So our math 9, we can go -2 to 0. Remember our vars, y vars function, y1 minus vars, y vars 2 dx. And to that we can add the integrations, another math 9, from 0 to 2. Now we're taking y2, so our vars, y vars function 2 minus vars, y vars 1, y1 dx. And if we hit enter, we end up with an area of 8. Again, you could do this by hand, but it's probably going to be a calculator question, and these points of intersection are not going to be nice, clean numbers, so we're going to store them into our calculator, which you all should know how to do. I show the second example, one, because I think it's kind of fun, and you know me, I like fun problems. So let's look at what we have here. We have 3 different functions given. I'm going to draw this a little on the larger side, just to kind of dramatize it. I like drama, you know me. So if we look at x to the third, nice cubic. That's a parent graph. We all need parents. Love your parents. We have y equals x plus 6. And that's going to come up like this. So, something like that. These two are going to intersect up there. And we have negative 1/2 x. So that's going to come down. It's going to come down like here, like so. So notice this nice region that's created in here. And you like say to yourself, well, that doesn't look too bad. But notice what's happening. Here, we start here, we'll call this A. As we travel through this region, our top curve is this linear function. Our bottom curve is this linear function. Or we have g of x up here, and we have h of x down here. So we integrate from a to some value. Well, if we integrate, well, what happens here at x equals 0? Well, at x equals 0, our top curve continues as g of x, but our bottom curve becomes x to the third. So it looks like here at 0, and we can go ahead and find that value through our calculator. To save us a little bit of time, we know that it's going to be 0. We know that from a to 0, our top curve is going to be g of x minus h of x dx. And then to that, we're going to add from 0 to this value now. We'll call it b. I'm not sure what it is at this point in time. From 0 to b, our top curve is still g of x, but our bottom curve becomes that f of x dx. So now I'm going to go ahead and, in my calculator, type in those equations. So I have my x to the third, I have x plus 6, and I have negative 1/2 x. Graphing those, here comes my graph. I can go ahead and find my point of intersection. So number 5, I'm going to move my cursor so I get over to that point. Hit enter, enter, enter. And notice it gave me 0, 0. That's a problem. Oh, what happened? If I go back to my calculate, I'm looking for my intersection. If I move my cursor, notice this here says y3 equals negative 1/2. Well, I know that's that graph, so I hit enter. And now it's jumping down to x to the third, my y1. I'm not interested in that. So I have to hit my up arrow so that I get to my other equation. Now I'm at y3. I want my y2. And I can hit enter and go ahead and enter, and I get the value of negative 4. So I know that my a value now is negative 4. I'm going to do the same thing, but now I want this linear function x plus 6 and this cubic. So when I do my calculate, find my point of intersection, I want my x to the third. That's a good function. And I want x to the 6, x plus 6. That's a good function. And if I hit enter, I'm going to get the point 2, positive 8. So I know my b value is going to be 2. So now I can go ahead and integrate. Well, what do I know about my equations? Again, g of x was x plus 6 or y2. So I have y2 minus h of x, which is going to be my y3. And to that I'm going to add my g of x, which is y2, minus my f of x, which is y1. So if I go back to my main screen, go to math, and 9, I'm going to integrate from negative 4 to 0 of y2, so vars, y vars, function, y2, minus vars, y vars, number 3, dx. And to that, I'm going to add another integration, math 9, from 0 to 2 of now y2 minus y1. Y vars, function, y1. Again, my variable of integration is x. Go ahead and hit enter, and I end up with the answer of 22. And that allows us to find the area of multiple regions, or even a more complicated region where we have to subtract multiple areas from each other.